Look up at the night sky. Thousands of galaxies drift in the dark. For centuries we assumed they were scattered randomly. We were spectacularly wrong. Zoom out far enough and something breathtaking emerges. The universe has a skeleton, a vast, luminous web threading every galaxy in existence. Scientists call it the cosmic web. Enormous filaments of dark matter and gas, connecting galaxy clusters like threads on an infinite cosmic loom. The resemblance to a biological neural network is uncanny. Filaments, nodes, voids. The largest structure in existence mirrors the architecture of a human brain. Even slime mold grows this way. Nature repeats its blueprints across scales we can barely comprehend, from microscopic fungi to structures billions of light years wide. These filaments are mostly invisible. Built from dark matter, they emit no light. Yet their gravity sculpts everything, pulling galaxies into long, sweeping cosmic chains. Early hints appeared in galaxy surveys. Structures like the Sloan Great Wall hinted at something enormous, organizing the cosmos far beyond individual galaxies. In the 1980s, the first redshift surveys mapped galaxy positions in 3D. The web appeared. Astronomers were stunned. The universe had hidden its grandest structure in plain sight. This structure spans the entire observable universe. 93 billion light-years of interconnected filaments, nodes, and voids. It is the single largest thing that exists. Our Milky Way is just one tiny bead on one thread of this infinite web. Everything we have ever known sits quietly on the skeleton of the universe. Filaments are not passive structures. They are active cosmic highways, channeling gas and matter across hundreds of millions of light-years. Each filament has a skeleton of dark matter wrapped in diffuse gas, with galaxies embedded like beads along its glowing spine. Where filaments meet, gravity wins. These intersections, called nodes, host the largest, most massive structures in the universe, galaxy clusters. Gas funneled along filaments accelerates toward nodes, compressing and heating as it falls into the gravitational wells of galaxy clusters. Individual galaxies feed the same way. Cold gas streams flow down filaments and into galaxies, fueling new star formation across billions of years. Our own Milky Way sits within a filament. The gas that built every star you can see tonight was once delivered along these invisible cosmic roads. This feeding process has been running for over 13 billion years, slowly building the massive structures we observe in the universe today. Simulations reveal a temperature gradient across the web. Cold voids, warm filaments, and blazing hot cluster cores. Each zone tells a different story. Dark energy complicates the picture. While filaments feed clusters, cosmic expansion simultaneously stretches the web, thinning its connections over time. Every galaxy is a passenger on these highways. The cosmic web does not just surround life in the universe, it actively built the conditions that made it possible. For decades, scientists faced a haunting problem. The math said ordinary matter existed, but nearly half of it had simply vanished from our observations. Astronomers could predict exactly how much ordinary matter the Big Bang created. But when they counted every star and galaxy, 50% was missing. This became known as the missing baryon problem. Baryons are ordinary particles, protons and neutrons, the stuff that makes yo-yo. Half were unaccounted for. The leading theory was bold. The missing matter was hiding inside cosmic filaments as incredibly thin, super-hot gas, too faint for telescopes to detect. Scientists called it the WHIM, the warm-hot intergalactic medium. Gas heated to millions of degrees, stretched so thin it was practically invisible. Then in 2020, using X-ray telescopes and a technique called fast radio burst analysis, astronomers finally confirmed it. The missing matter was found. The WHIM inside cosmic filaments accounts for nearly all the missing baryons. Half the universe's ordinary matter was threading the cosmic web all along. Enjoying these cosmic reveals? Hit subscribe and the bell so you never miss a mind-expanding episode. New cosmic wonders drop every week. Remarkably, this warm intergalactic gas flows like fluid through a living system. The cosmic web doesn't just look biological, it functions like one too. The universe had been hiding half its matter in plain sight. The cosmic web wasn't just a skeleton, it was also the bloodstream, carrying matter across everything. The cosmic web is not frozen in place. It breathes, shifts, and evolves across billions of years like a living organism responding to unseen forces. Dark energy, a mysterious, repulsive force, accelerates cosmic expansion. It stretches the web apart, pulling nodes away from each other at ever-increasing speeds. Filaments act as cosmic drains. They slowly siphon matter from the surrounding voids, feeding it into massive galaxy clusters at their intersections. Voids were once smaller and less empty. Over time, gravity and dark energy conspire to hollow them out, leaving vast cosmic deserts hundreds of millions of light years wide. Nodes grow monstrous over time. Galaxy clusters at filament intersections accumulate mass for billions of years, becoming the brightest, heaviest structures in existence. In the far future, dark energy wins. Filaments will thin and snap. Isolated galaxy clusters will drift apart, losing contact with the rest of the web forever. Our own Milky Way sits on a filament called the Pisces-Perseus supercluster chain. In cosmic terms, we are a single bead on an incomprehensibly vast string. The resemblance to a neural network is not coincidence in appearance alone. Both systems transport information and matter along thin threads between dense, active nodes. The observable universe spans 93 billion light-years. Every galaxy, every star, every atom of ordinary matter traces back to this single vast, breathing, evolving structure. We are not separate from the cosmic web. We are made of its matter, shaped by its forces, and threaded into its story. The universe, at its largest scale, looks startlingly alive. After this entire journey, we arrive at a humbling truth. Every galaxy in existence is just one tiny bead on an infinite cosmic web. Our Milky Way, home to billions of stars and everything we have ever known, is threaded onto this invisible skeleton like a single dewdrop on a spider web. The resemblance to a neural network is not just poetic. The mathematics governing both structures share striking similarities that scientists are still exploring. This web is not frozen. Dark energy is pulling it apart right now, stretching filaments thinner and pushing voids wider with every passing billion years. Even the missing matter mystery was solved here. Half of all ordinary matter hid inside these filaments as warm, invisible gas for decades before we found it. We mapped this structure not by seeing it directly, but by detecting the galaxies tracing its edges, like finding a spider web by watching where the dew collects. Future observatories will map the web in breathtaking detail, tracing every filament and void, finally revealing the full skeleton of the observable universe. At its grandest scale, the universe behaves eerily like something alive, circulating matter through vast networks toward dense, luminous hubs of activity. The same patterns that shape neurons, veins, rivers, and roots also shape the largest structure in existence. Nature repeats its genius at every scale. Look up. Every star you see is a bead on this web. The universe is vast, connected, and endlessly wondrous. Keep asking questions. The cosmos rewards curiosity.